Tag number 1 to tag number 10, we have mentioned the square type LED light, then LED downlight, then printer, Xerox, 6 ampere socket, 6 by 16 ampere socket, 6 ampere common socket, then 6 by 16 socket for oven, so 6 by 16 socket for tea vending machine, then 32 ampere socket for the special purpose. So that special purpose 32 ampere socket, what we will calculate the power point required for that. For example, by the same calculation, P means power is equal to volts, then ampere means current, that is I, and the last one is cos phi. But here, if the power is required for 32 ampere, it may be 3-phase. So for 3-phase, we need to multiply it by into root 3. So the into root 3 value for, if I convert the into root 3 value, that is 1.72. So I will directly multiply it by 1.72. So this is the one formula. So P is equal to 1.72 multiply. Now the voltage required for the 3-phase is 415. So this is the standard 415 voltage required for 3-phase. So, and the power factor is cos phi is the power factor, and that is 0.8. So simply again here we need to add that 32 ampere. So this is the formula for the 3-phase 32 ampere socket. So again P is equal to 1.72 multiply 4.415 multiply 32. So it will directly become like this: 1.72 multiply 415 multiply 32 multiply 0.8. So it will become 18,273 watts. So it has comes into the watts. The P is equal to 18,273. So this is the watts. The answer comes in the watts. So P is equal to 18.5 kilowatts. So directly I will put 18.5 kilowatts, and the voltage is 415. Same 50 hertz is there. The power factor will be 0.8. Diversity factor will be 0.8. So the answer comes, that is 273 kilowatts required for that, and the operating watt is 342.25 kilovolt ampere required. So by calculating these formulas, we have calculated an entire kilowatt required operating load. So required operating load in a kilowatt is 2196. So the round figure is 3000 kilowatt. The figure is 3000 not 3000 kilowatt. It will be 2200 kilowatt, and the operating load is around 2750 kilovolt ampere. So this is the value we has come, and this value is actually our power calculation or the power demand required for that office, that is 2200 kilowatts, and the 2750 kilovolt ampere is the total capacity of your transformer. So for that, for the office we require 2750 kilovolt amperes transformer. This is the transformer capacity, whereas this is the total power required. Total power demand. This is the total power demand required for that office area, that is 2200 kilowatt, as well as this is the transformer capacity for that office area. So we have calculated this entire office power demand calculation. So this is the way to calculate the power demand, by providing each and every factors, each and every requirement, so that we can calculate the power demand. This is just a single floor, small office area power calculation requires. Some cases we also we need to calculate the entire power demand for the entire tower. So for that we has to be take like this. The lift is also there. The one number lift is there. The second number lifts is there. The second number the common water pumps is also there. Third number the parking area is also there. For the parking area there is the ventilation fan. We need to calculate the power demand required for the ventilation fan. The 4 numbers, the other factors, the other equipment is also there. For example, the security office is there for the tower, and other pumps, the different types of electrical equipments for the firefighting. The other pumps means there is the firefighting pumps, and the fire hydrant pumps is also there, jockey pumps is also there. So different types of pump is there. So we need to calculate each and every kilowatt required for that entire equipment. So we can calculate the entire or the total power demand required for our tower. So this is just a single office area and a single office electrical load calculation. In that we have taken each and every equipment by the other things, like if there is the certain tower, so entire tower power demand we can, by calculating this kind of Excel sheet. For the power demand we need to calculate the electrical load, and the electrical load has the different phase, the quantity, the power input, and the voltage as well as the frequency. After that we have calculated brake load in a kilowatts and the connected load in the kilowatts. Connected load is always more than the brake load, that is the 20% more than the power factor. Power factor is common for all equipments, and the load factor. The load factor is also a certain division of the brake load divided by connected load. So the load factor is there. Then the diversity factor is also depend. The diversity factor is always given by the vendor of the square type LED lights or the printer, Xerox, the multiple equipment is there. So by that equipment, each and every vendor will give us the diversity factor for that certain equipment. By taking that diversity factor, we need to mention it over here. So automatically we can able to calculate the operating load, and the operating load is what? The operating load is nothing but the brake load multiply connected load multiply the load factor multiply the diversity factor. So by taking all these values and multiplying all these values, we can calculate the operating load of our requirement. And the next is operating load in a kilovolt ampere. So kilovolt ampere is required for the transformer. Transformer sizing is also important. When we calculating the operating load in a kilovolt, we can calculate the operating load in a kilovolt ampere also to calculate the transformer size. The transformer size is based on the actual power requirement or the power demand for that certain tower or the area. So by calculating the operating load in a kilowatts, we can calculate the operating load in a kilovolt ampere also. So this is the sheet what we have. This is the calculation sheet what we have done, and by calculating this each and every factors, we can calculate the operating load required for the certain office or the certain area. And this is the generalized equipment we have taken, like lifts, water pumps, ventilation fans. So by calculating the power demand required by this common equipments like lift, water pumps, ventilation fans, we can also calculate the entire tower power demand required for that. So thank you.